In earlier class, we have covered the transfer instructions in the lecture. Now it's time for the addition instruction. Any 8-bit number or the contents of register or the contents of memory location can be added by the contents of accumulator. The result is stored in the accumulator by default. There are two 8-bit registers can be added directly, or we can add it to the accumulator also. For example, this the contents of register B cannot be added to the contents of register C. Any 8-bit number, same is for the subtraction. Any 8-bit number or the contents of registers or the contents of memory location can be subtracted from the contents of accumulator. The result is stored in the accumulator. Means suppose my register is having suppose my register there is and register A, we can subtract the content of register A. Register B can be subtracted, means content or data. Register B can be subtracted from the accumulator. Subtractions can be performed in the 2's complement form. 2's complement and 1's complement is already covered in the digital electronics subject. Then the increment and decrement. Increment means the contents of the accumulator or particular register is incremented by 1. If in case of hexadecimal, if there is in case of hexadecimal, if there is a number in register B, or there is stored 1001, then by using this we can increment it and make it as 101. Same is the case for decrement. Decrement means we decrease it by 1. Then suppose for the arithmetic instruction, suppose add instruction is there. Add register or memory by add R means either there will be a register, add M means there will be a memory location. This can be done on the accumulator and the results are stored in the accumulator. It will also modify the flags. All the flags can be modified. If the result is result generates the carry, then the carry flag gets affected, means all the flags gets affected. So this is the instruction for the add. Then add with carry means there is a carry in the accumulate flag register, then add with the carry is will be affected. ADC B or ADC M. Okay. Then add immediate means there is a 8-bit data is provided, but that 8-bit data can be added directly to the accumulator. Suppose for example ADI 45 hex here. ADI 45 hex. ADI 45 hex instruction is executed and accumulator is having 00 hex. Then this 00 hex plus 45 hex. This 45 hex is added immediately and the output will be shown. Add accumulator with add immediate means if add accumulator immediately with the carry means 8-bit data and the carry flag instruction, just like ADC. ADC is operated on the register as well as the memory location, and here it is operated with the carry flag. Once the carry is there, then all the flags again gets dad D. Dad in the register pair. Dad refers for the contents of a pair. Add register pair. The register pair which is written after it. Suppose dad B is written. Means BC pair is added with the HL. BC pair is added with the HL pair, and the result is a 16-bit binary, and carry flag is set. Then next instruction is subtract. And first to subtract means register data from the accumulator and store the result in the accumulator. If suppose there is a memory location, then it will be defined by the HL pair, and all the flags are modified and similarly subtract as BB means subtract with borrow means there is a borrow flag gets affected and it will be subtracted data from the accumulator. Then next is the subtract immediate means we will provide with the data that is to be subtracted from the accumulator immediately. And SBI subtract immediate from accumulator with borrow means there is a borrow also means there is something in the carry flag, it will get rejected back and the subtraction function is performed with the immediate data. INR register and INR member means the register is incremented means plus 1, incremented means it means plus 1 either in the register the data stored in the register will be incremented by plus 1 or the data stored in the particular memory location is incremented by 1. That is INRB is for the register and INRM is for the particular memory location. So suppose if a memory location is there, then its address is specified by the contents of HLP. So we have to store it in the HLP. INX INX incremented by 1. INX the result is in the same. Then the decrement option. It decrements the register or memory by 1. Then it will give the -1 as output -1. Suppose the register B has 10 and 10 minus 1 will give you 01. 01 is given by the register B can be operated. The content of register DCX, then again the decrement, this is done for the register pair DCX and ICX. These are for the register pairs. Earlier in earlier case, in this case it is for the single register, and in DCX and ICX INX this is for the particular register pairs. DCX and INX particular register pair, these are for the particular register pair increment and decrement. INX is for incrementing and DCX is for decrementing the register. Next, the logical instructions. These instructions perform logical operations on the data stored in the registers, memory, and status tags. Logical operations include AND, OR, XOR, rotate, compare, complement. AND operations we have already studied in the logical circuits for the AND operations. AND, OR, and XOR. These are already studied in the DLEC. DLEC already. And rotate. There are two kinds of rotate right, left, and rotate with accumulator also is there. And then the compare instruction, we have to compare the two values. Then there is the complement. Complement means it will either cut. Complemented means just like a NOT gate. It will behave as a NOT inversion, not or inversion operations. Now next is the logical operations and or XOR. This can be done by the contents of accumulator means there is the ANDing operation, OR operation, and XOR operations are performed with the help of accumulator only. Without accumulator they can't perform. Suppose means one data is the accumulator, one 8-bit data, and another data in any register pair. Same is applicable for the OR gate and the XOR gate, and the result is stored in the accumulator only. And in the rotate is the logical operation for 0 to 1 is a 1 byte instruction. 1 byte instruction is there. This instruction does not require any operand after the operand. Simply I will write ROR, rotate right, rotate left. So this instruction are performed with the accumulator only. With the content of the accumulator and the result of the accumulator. RLC rotate accumulator left to carry flag. Means the content accumulators are rotated left with suppose register A, that is accumulator, has D7 to D0 data. That is, this data is stored in the accumulator before the instruction is having the value 100 10 10 10 10 and cy is equals to 0, carry flag is 0. Then after this rotate left carry, the first bit this first bit is transferred in the carry flag and the remaining bit same is there for the second time RLC. Then RL rotate accumulator left. Then again this is with the carry flag only. Then again the numbers are distributed, but here it's given as the 0. Means the complete instruction is executed and means the instruction each bit is shifted to the adjacent left position. Now it's shifting over and after that will happen this one. Suppose this is the data. This one is shown in the carry flag after RL and it is added with this cell. And in earlier case it is added to the 1. This is the difference between this RL and RL. Then RAR rotating the right RRC. You can call it RRC. Suppose again shifted to the adjacent right position. This is the cy equals to 1, cy equals to 0. Means what will happen? This one will be here after first RRC and one will be shown. Then again after second RRC this 0 will come ahead of this one. मीन्स फर्स्ट आरआरसी में क्या हुआ? फर्स्ट आरआरसी में लास्ट वाला जो 1 था वो सामने आया एंड कैरी टैगिंग पे 1 हुआ. सेकेंड आरआरसी में क्या हुआ? लास्ट में इधर 0, the 0 will come here and it is reflected in the carry tag also. Here 0 double 1 then 5 times 0 and the carry tag also the 0. Then RAR to carry it means each bit is shifted to the adjacent right position. Each bit right position हो जाएगा. ठीक है, पहला फर्स्ट क्वेश्चन स्टार्ट किया. मेरा इनिशियली नंबर क्या है? दिस विल बी द माय नंबर initially and carry flag as 0. Then where I will shift in this direction. Okay, I will shift in this direction. Means this last one will be shown in the carry flag and this one has shifted. Then there are only 7 bits, so I will put up 1 0 here. I will add 1 0 here, so it will become 0 1 and the 6 times the carry flag is 1. Then again what will happen? Second time RAR is there. Again the carry flag will come here as earlier carry flag is 0, so here it will come 0 the first area, but here in this case carry flag is 1, so this one will be reflected here and the last bit 0 will be reflected in the carry. Again I want to do the area, then 11